Hello everyone, welcome to my first ever video for this channel. Okay, so as you can see, the channel's name JW Math, Mathing with JW. So basically the main focus of this channel is to go through all the secondary school contents. Yeah, so my content, my video content will more, I will be giving more of examples instead of going through the contents, which will be very dry lah. Okay, so a little bit about myself. I've been private tutor for past 10 years, so I hope that my experience as a private tutor can help me or help you guys with your math. Okay, so let's start. So to start off today, right, I'll be going through chapter 1 of secondary school 1 topics. Okay, so basically the part 1 will be about prime numbers, trial division. So I'll be going through what are prime numbers, how do we use trial division to see which one, whether to test whether a number is a prime or a composite number. Then thereafter I'll go through index notations. Okay, lastly it will be prime factorization in this video. Okay, so first part, prime numbers. So what exactly are prime numbers? So as we all know, prime numbers are numbers that have exactly two different factors, one at itself. So let's say for example, okay, we have the number 2. Okay, so 2 equal to 1 times 2. Correct? So the factors will be 1 and 2. Okay, let's say for example 7. 7 equals to 1 times 7 only. Alright, so the factors will be 1 and 7. So these two numbers, 2 and 7, they are prime numbers. Let's give another example, 11. Okay, so 11 equal to 1 times 11. There are no other pairs. Okay, so all these 1, 2, right, these are what we call factors. Okay, so 1, 7 are also factors, and 1 and 11 are also factors of 11. Okay, so basically any numbers that has only 2 different factors, 1 at itself, they are referred as prime numbers. Okay, so next, composite numbers. So composite numbers are numbers that has more than 2 different factors. So let's say for example 4. Okay, so 4 equal to 1 times 4. Correct? Okay, 4 is also equals to 2 times 2. Right, from here we can understand that the factors of 4 are basically 1, 2, and 4. So since there are more than 2 factors of 4, so 4 is a composite number. Okay, let's look at another example. Let's say for example 10. Okay, so 10 equal to 1 times 10, definitely. Okay, so 10 also equal to 2 times 5, correct? Okay, so the factors of 10 will be 1, 2, 5, and 10. So since 10 has 4 factors, hence 10 is a composite number. So from here we understand that composite number has 2 or more different factors. Okay, so okay, lastly 0 and 1 are neither prime or composite number. Okay, where's my, okay, 0 and 1 are neither prime or composite. Okay, this is something for you to take note, right? Okay, let's move on. So is 21 a prime number or a composite number? Okay, so 21 is definitely equal to 1 times 21, correct? So any other pairs of factors of 21? So 21 is also equal to 3 times 7. So we all know from here, right, we can tell that, okay, 21 actually have how many factors? 1, 3, 7, and 21. Since it has more than 2 factors, so 21 will be a composite number. Right? Then how about 1, 2, 3? So 1, 2, 3 equal to 1 times 1, 2, 3. Right? Is also equal to, okay, so 1, 2, 3 is able to divide by 3, so equal to 3 times 41. Right? Do we need to proceed with more factors? Don't need, because since it already has more than 2 factors, so this is also a composite number. Right, then how about 157? Okay, so let's look at 157. So 157 equal to 1 times 157. Any other factors that 157 is able to divide? Is it able to divide by 2? No. 3? No. 4? No. Okay, so if 157 there are no other factors, so 157, right, is a prime number. Right, okay. So these are examples of prime and composite numbers. Okay, so let's move on. Trial division. So how do we use trial division to actually test a number, whether is it a prime or a composite number? So let's look at the number 56. Okay, so let's see if we key square root 56. Okay, square root 56 into our calculator. Okay, so square root is this thing on your calculator. Okay, if you are first time using the square root. Okay, square root, so you key that button first, then you press 56. You will actually equal to 7.48. Okay, so the largest prime number for this case will be 7. Okay, so largest prime for this will be 7, correct? Okay, largest prime is equal to 7. Okay, so let's see if 56 is able to, so we write down all the prime numbers between 2 to 7. It will be 2, 3, 5, and 7. So is 56 divisible by 2? Yes, 56 equal to 2 times 28. Correct? Okay, so since 56 is divisible, since 56 is also equal to 2 times 28, so 56 is a composite number. Give me a second. Where did my pencil go? Okay, composite. So how do we use this trial division is, once we get the largest prime, which is 7, so we test out from, see whether any of the factors between from 2 to the largest prime, that 56 will have any factors. Okay, so let's take a look at another example. See, we use trial division to test whether 79 is a prime or composite number. So let's say, for example, today we have square root 79. So we square root first, equal to, we key square root 79. Okay, equal to 8.893SF. Okay, so the largest prime that 79 can go is, again, 7. Largest prime, we write it as LP. Okay, largest prime equal to 7. So the prime numbers between 2 to 7 is 2, 3, 5, 7. So let's check. Okay, so can 79 divide by 2? No. So there's no factors so 2 is not a factor of 79. Okay, Can 79 divide by 3? No. Okay. 79 divided by 5? No. 79 divided by 7? No. So all these four numbers, they are not factors of 79. Hence 79 is a prime number. Okay. All these four, they are not a factor. Okay, from the 12 division. Hence 79 is a prime number. So that's how we use 12 division to find out whether a number is it a prime number or a composite number. Okay. If you guys have any questions right along the way, you may drop down in the comments section, and I'll try my best to explain right to you. Okay, so that's 12 division. Maybe we can look at another example whether let's say for example a 53. Okay, so is 53 a composite or prime? Okay, so again we use 12 division. Okay, so what do? Is we square root 53 first. Okay, square root 53, we get 7.2. Okay, so the largest prime again is 7 LP. Okay, so the prime numbers between 2 to 7 is 2, 3, 5, 7. Okay, so can 53 divide by 2? No. Okay, can 53 divide by 3? No. Can 53 divide by 5? No. And 7? No. So 53. So all these four, right, they are not a factor. Correct? Hence 53 is prime number. Okay, so that's how we use 12 division to find out whether a number is a prime or composite number. Right? Okay, good. So next we will move on to index notation. Okay, so as you can see here, 3 times 3 times 3 times 3 times 3. So 3 times itself 5 times. So it can also be written as 3 to the power of 5. So the 5, right, basically you write 3 at the bottom and then the 5 at the top, slightly above. Okay, so this is what we call it 3 to the power of 5. Okay, where 3 is the base. Okay, so this is the base and 5 is the power. Okay, give me a second, let me rewrite this. So 5 is power. Okay, so 3 to the power of 5 is index notation for, so this 3 to the power of 5 is index notation, okay, for 3 times 3 times 3 times 3 times 3. Why do we do this? Because we are mathematicians are lazy, hence they find a way to represent this 3 times 3 times 3 times 3 as 3 to the power of 5. Okay, yeah. Okay, so write down the index notation for the examples below. Okay, so this will be 11 times 11 times 11 times 11, so it will be 11 to the power of 4 times itself 4 times. This will be 2 to the power 2. Alright, this will be 9 to the power 3. Okay, so these are index notations. Okay, how about writing this into your expand this. So 4 to the power 3 equal to 4 times 4 times 4. Okay, 5 to the power 4 will be 5 times itself 4 times, 5 times 5 to 2 times, 3 times, 4 times, and then times 2. Okay, 3 to the power 3 will be 3 times itself, 3 times, 3 times 3 times 3. Okay, times 4 to the power 2 times 4 times itself 2 twice. Okay, so for times 4 times 2. Okay, so this is how we write index rotations, convert index rotation into normal equations. Okay, vice versa is the example above. Okay, yeah. So after learning index rotations, we will need to understand how we can use it to help us with the prime factorization. So a composite number, right? So recap again. What are composite numbers? So composite numbers are numbers that has more than 2 factors. Okay, more than 2 factors. Okay, so composite numbers can be expressed as product of its prime number. Okay, so let's say for example 24. Okay, so the example I give you here is 24. Okay, 24 equals to 2 times 2 times 2 times 3, or can be written as, so index rotation 2 times itself 3 times, so 2 power 3 times 3. Okay, so this is the prime factorization of 24. Okay, so do remember, when we do prime factorization, right, what's the key? The key is the factors must be prime numbers. Can we write as 4 times 2 times 3? Although it gives the same number, but this is not prime factorization. Okay, this is just factorization. Okay, 24 is also equal to 3 times 8, correct? But is this a prime factorization? No, it's not. So we need to take note of this, that when we do prime factorization, to make sure that the factors are prime numbers. So let's say for prime numbers are 2, 3, 5, 7. These are the common prime numbers that we have. Okay, good. So let's look at the 3 examples we have. So how do we do prime factorization? So okay, so 1, 2, 4. How I will do our prime factorization, right, is, okay, so to start off, we'll divide by this by a prime number. Let's say for example I divide by 2, so it will be 62 again, so I can divide by 2 again, correct? Then it will be 31. Did I do it correctly or not? Okay, can 31 divide by any prime numbers? Okay, so 31 will be just 31 and 1, correct? Okay, so how I rewrite this 1, 2, 4 as its prime factor will be, since 31 there's no more prime factor, so we'll leave at 31. So 1, 2, 4 will be equal to 2 times 2 times 31, which will be equal to 2 to the power 2 times 31. Okay, so this is the prime factorization of 1, 2, 4. Okay, got it? Okay, let's move on to another example. 68. So again, 68 divide by a prime number. Start off with our prime numbers, 2. So you have 34 divide by 2 again, you have 17. So 17, so divide by 17 equal to 1. Okay, so 68 equal to 2 times 2 times 17. Okay, so equal to 2 square times 17. So prime factorization of 68 will be 2 square times 17. Okay, last example we have. Okay, so 135 again, so 135. Okay, so I will go with 5 first. Okay, so cause it's obvious that you can divide by 5, so okay, 135 are 2 times 5, 10, so left with 35, so 27. Okay, so 3, 9. Okay, 9 can still divide, so I divide by 3, I have 3 more. Okay, okay, divide by 3 and left with 1. Okay, do remember when you do prime factorization, right, the last number here must be 1. Okay, so your 135, our 135 is actually equal to 3 times 3 times 3 times 5. Okay, which can also be written as 3 to the power of 3 times 5. Okay, so that's prime factorization. Okay, so a small tip that I have here, okay, or even when we do this prime factorization, so all even numbers, right, are divisible by 2. Okay, and any number sum of its digit is divisible by 3, then 3 is a factor of this number. Okay, what do I mean by this? Okay, so let's say for example we have a number, okay, we have a number 1, 2, 3. How do we know whether this number 1, 2, 3 is divisible by 3? Okay, very simple. We just sum the digits up. So 1 plus 2 plus 3 equal to 6. Okay, and 6 is a multiple of 3. Okay, or I can say that 6 equal to 2 times 3, right? So 3 is a factor of 6, then 3 will be a factor of 1, 2, 3. Okay, so you can actually divide by 1, 2, 3 by 3, you get 41. Right? Okay, let's take a bigger number, for example 2196. Okay, how do we know whether this number, okay, 2196, is it a multiple of 3 or not? Very simple. So we just add them up. 2 plus 1, 3. 3 plus 9, 12. 12 plus 6, 18. Okay, so 18 equal to 3 times 6. So since 3 is a factor of the sum of its digits, okay, therefore 3 is a factor of 2196. Okay, so 2196. Next, just double check. Okay, so 21 divided by 3, I have 7. Okay, 9 divided by 3, I have 3. And then 6 divided by 3, I have 2. Alright? Yeah, so it's proven that 3 is a factor of 2196. So that's how you check whether a number that has 3 as its factor. Okay? Yeah, so next, any number that its last digit is 0 or 5, then 5 is a factor of that number. Okay, so very straightforward. Let's say for example 20. Okay, last digit is 0, so 5 is a factor. 1555. Okay, last digit is 5, then 5 is a factor. Okay, very simple, straightforward. Okay, yeah, so let's move on. Okay, let's try to, okay, so let's do this exercise 1A. I'm not sure if you are able to see this question clearly. So Ali wants to use 200 and, okay, so we have this magic number 210. Okay, Ali wants to use this 210 1 centimeter cubes to make a cuboid. Okay, so we know that a cuboid looks like this. Okay, yeah, so cuboid make up of length times breadth times height. Okay, this is something that we need to put in our head. So okay, so such that each of its sides is longer than 1 cm. Okay, so each side is longer than 1 cm. There are 6 possible cuboids that he can make. So find the dimension of any 3 of them. So dimension is basically length times breadth times height. Okay, so how do we go about approaching this question? So we need to know what's the length, what's the breadth, what's the height. So before we do that, we need to find out what are the factors of 210. Okay, so we find out the factors first. Okay, 2. Okay, 210. Okay, so we find the prime factor first. So 2, I have 105. So then I divide by 3, I have 35. Then I divide by 5, then I have 7, so I have 7, 1. Okay, so from here we know that 210. Okay, sorry, I'm using a very cheapskate homemade Apple pencil. Okay, next time I can show you all what's the pencil that I'm actually using. Okay, 210 equal to 2 times 3 times 5 times 7. So very simple. They say find the dimension of any 3 of them. So basically you just need to make any combination. So 2 times 3 times 7 times 5, which is 35. This is one of the combinations, first one. Or you have a second one, 2 times 15 times 7. Okay, this is second combination that you may have. 3, you can have 6 times 5 times 7, right? Basically you combine this. Okay, you combine any 2 together to form 1, and then you give another. Let's see if you can get all 6. Okay, so 4 will be 2 times 5 times 21. Okay, 5 will be, let's say, 3 times 5 times 14. Right? Okay, the homework for today will be find for me what's the last one, last pair of dimension for this answer. Alright, okay, that will be the end for today's video. And then if you have any questions, do drop down in the comments section. I will try to answer your question as soon as possible. And I do have a Instagram page, so do follow for latest update. Alright, okay, thank you for tuning in, and we will see you again. Bye bye.